Hi guys, we will move to the next topic, that is B trees. So what is a B tree? So B tree of order M is a M-way search tree or a balanced sort. And where these B trees are used is, it is used in external sorting. So what is this of order M? So before going to see the properties, we will see how the elements can be inserted in the B tree, and here it is given, these are the values given or keys you can say, and here B tree of order 4, that means you have to construct a B tree of order 4, so that is order M. So if it is of order 4, M equal to 4, then the number of keys in a node can be M minus 1. That means 3 values we can store in one particular node. That is nothing but order M. Order M is M minus 1 elements can be stored in one particular node here. So the number of keys in a node is M minus 1. What is M given here? 4. So now let us start inserting an element. So the element you have is 5. And what is the order given here? 4. That means you can have, or in one particular node, we can accommodate 3 elements here. So first is 5. 5 you have inserted. Now what's the next element you have? It is 3. So when you are inserting 3, again we have to check with the property of a binary search tree. So the element should be less than, and here to the right it should be greater than. So 3 is less than 5, so 3 will be to the left side of 5. So that is 5 and 3. Now what's the next node you have? 21. So 5 is greater than 21. Now in this place you are 21 here. Okay, so we have done 21. Now coming to the next one. What's the next value you have? 9. So where you can accommodate 9? The 9 will be between 5 and 21. Okay, I'm writing 9 here. The 9 can be accommodated between 5 and 21. So I am writing. But here we have a property. It is of order 4. Order 4 is nothing but only M minus 1 values only you can accommodate. But how many values you have here? 4 values you have. You have 4 values here. It cannot accommodate 4. So in that case, what we have to do is, we have to select one element and we have to move that element to the topper level. We have to select one element from this and we have to move that particular element to the topper level. So how to select now? In these 4 elements, we have to select the middle element now. So 1, 2, 3, 4, it is even number. So if it is an even number, you might be getting 5 as a middle element, or you may get the 9 as a middle element. So you may select 5 or you may select 9. If you are selecting 5, this becomes the left median. If you are selecting 9, that becomes the right median. So either you can select 5 or you can select 9 here. But if you are selecting 5, throughout the problem you have to select the left median only. This is a left median. This is left median. And if you are selecting 5, that means you are going with the right median. So throughout the program, throughout the problem solving, you have to go with the right median only. So now here I am considering the left median. So in actually we had 4, but how many it will be accommodating? 3. So since it is accommodating only 3, what we are doing is, in these 4 we are selecting one element as a middle element. So this middle element I have selected as a left median now. So now what we have to do here is, after selecting this 5, now this 5 will be moving to the topper level. Now one level top it will go. So now one level top it will go. That means the 5 will become the root now. So 5 will become the root. That means again it can accommodate 3 children here. So, and when it is going up, Now this is divided into two parts. This is one part and this is another part here. So when it is left, the 3 will become the left of this, the left child, and 9 and 21 will become the right child. So now the 5 is the root, now 3 is a left child and 9 and 21 are the right children. So 3 is a left here, again each node I said 3 values, so 3 values, 3, and 9 and 21 becomes the right children. This is 9 and 21. So we have completed 9. Now what is the next element you have? 1. So when you want to insert 1, you should compare with the 5. We should not insert in the root. We have to just compare with the 5. So 1 is less than 5. So since 1 is less than 5, you have to insert 1 as a left child now. So 1 you have to insert as a left child. So 1 we will be getting here. So 1 will be getting here. Already you have 3 here, and already I said the smaller element should be towards the left and the bigger element should be towards the right. So 1 will be coming the left here. 1 is coming left. And here you have 3. 5 left child is this and 5 right child is this. Now the next one, what is the next element we have now? After 1, the next element you have is 13. 13. Now you compare 5 with 13. So 13 is greater than 5. So since 13 is greater than 5, it should come to the right child now. So it should come to the right child. So 13 will be coming between 9 and 21. 13 will be coming between 9 and 21. So here you are accommodating. Now, also next child you have after 13 you have is 2. Now compare with the 5 now. So the 2 is less than 5. So since 2 is less than 5, the 2 will be coming towards the left child now. So 2 will be accommodated between 1 and 3. Yes, this is also finished. So 2 is finished. Now next child you have is 7. 7. So compare now, 7 is greater than 5, that means it should come to the right child now. So 7 should be to the right child, and this 7 will be before 9. So 7 will be before 9. But how many you have here? 4. But how many we should have? We should have only 3. So now, since you should have only 3, now what we have to do again? From this, we should find out the middle element. The 2 middle elements we have when it is even. 4, right? So 2 middle elements you have. It might be 9 or it might be 13. In the starting we have considered left median. So here also we have to consider the left median now. So 9 will be considered as a left median. This will be considered as a middle element, and this will be moving one level top. We have here is one level top. That means 9 will be accommodated in the root node. So 9 is accommodated in the root node now. So this is 1, 2, 3 left, and this is now 9 is accommodating here. When 9 is accommodating, what will happen? This is split into two parts. So 9 left child will become 7, 9 right child will become 13 and 21. Left child is 7, 7 is less than 9, and 13 and 21 are greater than 9 here. So in this way we have completed 7. Now coming to the next one, 10. Now again check 10 now. So 10 is greater than 9. So since 10 is greater than 9, that means it should accommodate in the right children now. So now we have space here. So now 10 will be accommodated here. Now what's the next one you have? 12, 4, 8 we have. The next still we have is 12, 4, 8. Now check for 12 now. So again 12 is greater than 9. So since 12 is greater than 9, again the 12 should come to the right child now. So I am accommodating 12. The 12 should be between 10 and 13. 10 and 13. But how many you have? 4. So since you have 4, what we have to do? We have to find out the middle element. So these two are the middle elements. Since we are going with the left median, now 12 will be moving up now. So 12 is moved up. So since 12 is moved up, now what will happen? the 10 will become the left child and 13 and 12 become the right child of 12. So 10 is becoming the left child and 13 and 21 is becoming the right child. So 12 we have done. Now come to the 4 now. So 4 is less than 5. So since 4 is less than 5, the 4 will be coming to the left children now. So now here the children. But again we have 4. So since we have 4, again we have to pick up the middle element. So middle element is 2 now. So now this 2 will go here. So when 2 is goes here, again you have 4 here. The rest everything is same. Again you have 4. So since again we should not have 4, again what we have to do, we have to pick up the middle element. So what is the middle element now? 5. So 5 will be moving up. So when 5 is moving up, 2 will become the left child and 9 and 12 become the right child. 2 and 9 and 12 are becoming the right child. And here, since 2 we have split it here, 2 this left child is 1 and 3 and 4 will become the right children. 1 become the left and 3 and 4 become the right children. And similarly the rest everything. Now the next one you have is finally 8. So if you take 8, 8 is greater than 5. So since 8 is greater than 5, it should go to the right here. So again we should only insert in the leaf nodes only. So if you take again 8 is less than 9. So 8 is less than 9, that means it should be the left child. So it should be the left child. So again 8 is greater than 7, so it is coming here. So this is the B tree. And if you observe here, these are the properties I have given. The root node has at least 2 children. At least 2 children the B tree will be having. How many children you have? 2. It can have more than 2, but minimum 2 it should have. And all the nodes other than the external nodes has at least m by 2 children. M is here, I said 4. So 4 by 2, it is seal. So 2 children it should have. 2 children it should have. If this you take this as internal nodes here, it should have at least 2 children. 1, 2, 1, 2, 3. At least 2 the internal nodes should have. So these are the properties the B trees will be satisfying. And one more thing also, all the leaf nodes will be under the same level. The same level. So that is one example. Now we'll take one more example. All these are the values what we have, and we will take order equal to 5. So if order equal to 5, how many elements you can accommodate? We can accommodate 4 elements. So first 5, next 12, 12 is greater than 5, next 14, next 1. So 1 is smaller, so 1 should come first. Now coming to 4. So 4 means it will be first 5, 12, 14, now 1. So up to here we have done. Now next we are getting is 2. So 2 you will be accommodating between 1 and 5. But here how many it will be accommodating? 4. But how many we have here? 5. So what we have to do now? We have to find out the middle element. It is odd. It is odd. Then finding the middle element is easy. Now which is the middle element now? 5 is the middle element. So after finding the middle element, now this 5 moves one step up. So y is moving one step up now. So 5 left children are 1 and 2. 5 right children are 12 and 14. So 2 we have completed. Now coming to 4. Now compare with the root node. 4 is less than 5. So it will come to the right, left child now. Left child. This 4 we have completed. Now next 18. So 18 is greater than 5. So since 18 is greater than 5, it will come to the right children now, child. So 18 is coming to the right child. Now what is the next 18 we have done? Now next you have is 19. So 19 is again greater than 5. So it will come to the right. So it will come to the right. Now next after 19, now next you have is 17. Again 17 is also greater than 5. So 17 will be accommodated between 14 and 18. 14 and 18. But again, how many you have? 5. So since you have 5, again pick up the middle element. So this is the middle element, so that will be moved one step up. One step up. So 17 left children will become 12 and 14, and 18 and 19 will become the right children. So we have done 17. Now next, 15. So 15 is less than 17. So since it is less than 17, it will come to the left child of 17. So left child of 17. So 15 we have done. Now next is 25. So 25 is greater than 17. So it will come to the right. So 18, 19, 25. Right. Now after 25 we have done. Now next is 24. So since it is 24, again it is greater than 17. So it should come to the right now. So right. So 18, 19, 24, 25. So after this 24 we have done. Now next is 22. Again 22 is greater than 17. So since it is greater than 17, now 22 will be between these two. So again you have 5. So since you have 5, again find the middle element. So since it is a middle element, now it will move up now. It will move up. That means these two will become the left children and these two will become the right children now. This is 22. Now come to 11 now. So if it is 11, 11 is less than 17. So since 11 is less than 17, the 11 comes to the left child of 17. So left child of 17. Now this is 11. Now next you have is 30. So again you compare. 30 is greater than 22. So since 30 is greater than 22, 30 will become the right child now. So 30 is becoming the right child. Now after 30 we have done. So next you have is 31. So 31 again you compare with 22. 31 is greater than 22. So greater than 22. So it comes to the right child. Now after that 31. So next you have is 28 and 13 we have. Two more we are left over. 28 and 13. So 28 is again greater than 22. So again it will be coming to the right. So this 28 will be accommodated between 25 and 30. So you are accommodating here. But again you have 5. So since you have 5, now what will happen? This 28 will move one level up. So 24 and 25 will become the left child, and 30 and 31 will become the right child of 28. So 28 we have done. Now last child we have is 13. So 13 is less than 17. Less than 17, so it becomes 13 becomes the left child of 17 now. So left child of 17. So that will be between 12 and 14. Now again we have 5 elements here. So since you have 5, again pick up the middle element. So when you pick up the middle element, what will happen? This 13 will move up now. So when 13 is moving up, now 13 will be between 5 and 17 now. So 13 will be between 5 and 17. So again in the root also you are getting 5. So in the root also you are getting 5. Again pick up the minimum, it's a middle element here. So what is a middle element now? 17 is a middle element. So 17 will be moving one level up now. So this 5 and 13 will become the left, and 22 and 28 will become the right. So 17, 13 left. So remaining as it is. So this is the left child, you draw it properly, and this is the right child. And 28, the right child is 30 and 31. So this is the B tree.